Good evening.
Hi, Darryl.
Yeah.
Just formal. Yeah, so tonight, wow. I'm going to probably tell you things that you have no idea about. But I guess I'll start off by saying this is what I did before I touched law. Okay, so I was fairly heavily involved in internal combustion engines and the proper tune spec for internal combustion engines. And I did this for about 12 years, and I helped develop a publicly available kit that could be mounted on your passenger car engine, and it would be more tunable. So this is a piston-based world. Would I get an agreement on that? It's a piston-based world.
It's a big piston, I think you're right.
Yeah, I know. If I be very careful saying that. It is a piston-based world, and as such, as much as the powers that be want to change that, it's time to know the truth about that piston engine. And it was as much of a shock to me when I first learned this as I dare say it will be to you, but I was a bit of a petrol head through my early teens. As long as I can remember, I was playing with cars and engines. My uncles and my family were engineers, so it was just natural to me. And then I discovered the truth, and it meant pretty much putting all that I had learned aside, and I realised that we'd been lied to. And especially the hot rod industry, so those that were modifying their own motor cars or building their own motor cars, there was a lie that was out there. And that lie essentially led to going back to, in history, to the man who invented the four-stroke engine, the internal combustion engine. His name was Otto, O-T-T-O. Otto applied himself scientifically to that engine when he developed it. This was back in the mid-19th century. So there were no petrol stations. There was the only fuel that we were utilising then was what was called town gas. And he then developed this piston engine, four-stroke engine, to run on that town gas. Okay, so that engine was designed by the inventor to run a dry fuel. Okay, and he then laid down the law for that engine. So in order to tune that engine, you must follow his steps in tuning, and it's strict. And the first rule is that that engine must be kept at an even temperature while it's running. So if it's a 4-cylinder engine or a 6-cylinder engine, it must be an even temperature. There can be no more than, in our modern temperature scale, no more than 10 degrees Celsius variation over that whole engine while it's operating. If you get more than a 10 degrees Celsius variation, then the engine becomes untunable. And in fact, it starts to put out excess unburnt fuel, and it wears out fairly quickly. Okay, and that's the world that we've been living in. All the piston engines around the world have been basically, they've ignored that first rule that Otto established. And as a consequence, we're now breathing, especially here in Melbourne, if you're around Altona, that's just 24/7 trucks. And the pollution there is causing health problems and has for many, many years. So you're breathing unburned fuel as a result of Otto's first rule being ignored. And yet the first motorcar manufacturers, the like of Henry Ford, Mercedes and the like, they had some understanding of temperature control in an engine. And to the point where if I was to take you back in a time machine to 1933 and spinning around, and I'd take you to a Ford dealership, and spinning around in the middle of the showroom floor was a 3-window coupe with a side valve V8. And on the windscreen, Ford Motor Company had a little sticker, and that sticker had S.F.C 30 miles to the gallon. So that SFC stood for specific fuel consumption, guaranteed by the Ford Motor Company. Didn't matter whether you were Harry Hot Rod or you just drove that car once a week to church, would give you 30 miles to the gallon, guaranteed by Ford Motor Company. And that was fine right up until World War II. Then after World War II, there was a massive shift. And the engineers were asked to basically step away because the demand on motor cars was overwhelming, and the accountants took over. And they said, let's trim this engine down so that it's more economical for the mass producers, Chevrolet, Ford Motor Company, Chrysler, Studebaker. Many car companies were starting up and had done prior World War II. But after World War II, there was too much demand. So they changed the cooling system design on that early engine. And as a result of that, Ford had to take away that sticker stating 30 miles to the gallon guaranteed. All of a sudden, they were getting 15 miles to the gallon. And they thought, wow, what have we changed? We've done something here, but they didn't quite understand it. Some of the engineers, of course, did, but they were being ignored. They weren't working for Ford and Chevrolet at the time. The accountants took over. And they thought, we've got lots of oil, let's just keep going. And they did, and that V8 is no better today than it was back at the end of World War II or the early 1950s. And they just accepted it. And it was putting out a lot of unburnt fuel. They had to actually, because the temperature was not being controlled, the internal combustion was not being controlled, they had to richen the mixture up. They had to put more fuel into that engine to make it survive. And we got used to, and mechanics were trained to keep the engine rich. Pour lots of fuel in there and it'll be right. We don't care, we've got lots of fuel. And then the other consequence, of course, was the engine was wearing out. And they started blowing head gaskets. They had a very sensitive cooling system. They were blowing head gaskets, but mechanics were trained then to go, well, if we blow a head gasket, we'll just put another one in, and we'll just keep putting Band-Aids on this engine, and we'll keep putting Band-Aids on it. And they put controls. They thought, we'll change the control system. for control of fuel. We'll change the exhaust design. But they had lost sight of Otto's first rule, which was to maintain the correct temperature range. There was one Italian company in the early 1960s, Fiat. They woke up to it and they released one model of engine, which went into one model of car in 1964, and that engine performed extremely well. Its temperature was controlled, and it was a very good, reliable motor car. But it only lasted for one model. And they changed the whole design, and they didn't even realise what they were doing. But there were some people that did know, and I was lucky enough to come across one of those people. And I worked in with him back in 1989, and we developed a cooling system kit, like I said earlier, that you could put into a standard motor car, and a mechanic could then properly tune that engine. And it just changed the way the engine performed. It was rather a radical change. I was in shock. As a petrol head, I couldn't quite believe what I was witnessing. The exhaust note changed, the way the engine behaved, it was just like it was a totally foreign engine. I just couldn't get my head around the massive change that it made. And what we developed essentially was a relocation. And for those who are familiar with engines, hand up those who know anything about something about engines. Yeah, okay, cool. So we know what the thermostat is. So we developed this. This is a thermostat housing. Okay. I'll pass it around. This was actually the first one that came off our production line. And this allowed us to put the thermostat in the proper spot. In a traditional internal combustion engine, 4-stroke, the thermostat, you've got water in to the engine and you've got water out. And the connector is what's called the radiator or the heat exchanger. So we developed this kit to take thermostat out of the outlet of the engine, so the coolant going through the engine and then out to the radiator. We took it out of there and we put it into the bottom radiator hose, which is coming from the bottom of the radiator up into the water pump. And the water pump then distributes the coolant through the engine, and it gathers up all the heat and travels out to the radiator. So we put that control mechanism into the bottom hose. So we put the thermostat, so the thermostat lived between the radiator and the water pump. And then we had a special fitting we put in the top of the water out. And there's a specific way that this fitting goes in.
Sorry, what was that one?
This one?
No, the other one.
This goes into the top radiator hose. Yeah. Right? So you've got coolant coming out of the engine and it goes through this fitting here. And we've got an elbow that comes out of here. And we've got a bypass line. So this sits between the radiator and the water pump. And we've got an allowance in the housing for a bypass line to come out of here and then to the thermostat housing. And in between, we have a little T-piece. There was a fill area. There's a brass fitting where I could put a funnel. And I could actually fill the system and bleed the system. and then the coolant would come out of here. In fact, all we found that was heading to the radiator was the steam, was the extra hot coolant that was heading to the heat exchanger to then get converted back to a liquid ready to re-enter the system. And we found that the thermostat was only opening, allowing fresh mixture of coolant from the radiator when, depending on your throttle position. So we found that only at wide open throttle was the thermostat open all the way. Okay, and there was a continual cycle of coolant from the engine through this fitting into the thermostat, tickling the thermostat, and then up into the pump. So you had you had a constant flow of coolant from the moment you started that engine. And that was crucial, absolutely crucial. So what do you think the temperature is inside the combustion chamber when the motor first starts? Anyone?
10.
The moment that first explosion.
It's an explosion. It's got to be hot.
How hot?
Can't be instant. I don't know. 1,000 degrees.
It's 875 degrees. It goes from ambient to 875 degrees instantly.
That's incredible.
And it's the exact amount of energy as one stick of gelignite.
Holy
Wow.
shit.
As soon as you start the car.
As soon as you, that's in one cylinder.
Oh my God. 875 degrees, did you say?
875
You
degrees.
mean that's what happened?
That's what the internal
As
combustion
soon as you say
does.
The
It's
car.
an explosion, yes.
Now,
Gelignite, yes.
I can say this comfortably because I've helped John. I haven't helped John in all of his work. He's been doing this stuff for many years before me. But his name's John Bennett. He spent 30,000 hours on engine dynos. 30,000 hours. Just put that in time. That's a long time.
So
Okay.
that, what you talk, if I may, what you talk about, there's a preliminary bypass temperature control thing, like before you're waiting for all the water to heat up, it's a temporary water engine temperature thing, whatever.
It's instant.
It's instant, yeah.
It's instant. So, question.
So the
What's the hottest part of the engine?
The head.
There's a component. There is a component inside that cylinder head that is the hottest. No,
it blows
The surface of the piston.
no,
The gas in the valve.
bottom of the
No.
engine.
Oh,
Because of the
the
explosion.
radiator.
no,
The bottom of the engine is the explosion.
no.
Part of the head's the hottest.
Yeah, it's a part of the cylinder head. Okay, you've usually got two valves.
Rings.
It's a 4-stroke engine. No, it's not. It's a 4-stroke engine. So what does 4 strokes? What are those 4 strokes?
4 cylinders.
No, it's suck, squeeze, bang, blow. Suck, squeeze, bang, blow. Suck, squeeze, bang, blow. 4 strokes. Suck, sucking the piston's traveling down the bore. The intake valve is open. There is an air fuel charge coming into the cylinder, and then it's suck, squeeze. The piston's now heading up. It's squeezing that air fuel, and the camshaft timing and the spark timing is set up so that that spark plug fires at the exact moment to cause the maximum explosion inside. So you've got pressure and you've got this air fuel volatile mixture, and it all happens at once. Bang! There's your 875 degrees. There's your energy equivalent to one stick of gelignite going off to shove that piston straight back down. So suck, squeeze, bang, and then the pistons travel down. The intake valve shuts, the exhaust valve opens, and the piston travels up again to evacuate all of the burnt products of combustion. So what's the hottest part?
The air.
No,
Fuel.
no. It's a component.
In the head.
It's in the cylinder head. And it's a key to the whole internal combustion engine. Until you know what that component is and how critical that is, that we need to understand this, because it is a piston-based world. Pistons are, those sticks of gelignite are going off thousands of times, tens of thousands of times. You know, it's mind-boggling to see an engine operated.
See, the piston rod broke, so
No.
there is must be somewhere around there.
No, it's the exhaust valve seat. Okay, so when that exhaust valve is opened, you've got all this hot air that's traveling out past the valve, going past the seat, and then the exhaust valve has to shut, and the job of the valve seat is to get rid of that heat that the valve has just been exposed to, because all this hot air has traveled past that valve. The head of that valve is literally glowing red hot. So the job of the valve seat is to shut, and the valve seat is supposed to disperse and grab all of that heat out of that valve and pull it into the seat and into the cooling system. Because the cooling system, there's coolant traveling over the back of that valve seat, and its job is to pull that heat away as quickly as possible. So it's the number one job is to get that valve so that the seat and the valve maintain a particular temperature. It is crucial, because what happens if the temperature goes over? If that valve can't get rid of that heat and the valve seat cannot get rid of that heat, what happens?
Engine heats up.
No. What happens? The valve seat distorts. Okay? It distorts and it leaks.
No, timing goes.
No. You end up, and I've shown this when I was, I had to do my LPG installation course many years ago at Dandenong TAFE, and they had a dyno, a chassis dyno there. And I was able to display this to the teachers and to the students, and they were all blown away. These are Dandenong TAFE teachers teaching motor mechanics. Right, these are people that have been in the trade for all their lives, and they'd never even confronted what I'm telling you today. And I got one of their students' cars and I put it on the chassis dyno, and it was a V8 and it had extractors, so you could actually see the extractors, the pipes coming off the engine. And I held it at 3,000 revs and I got it hot enough so that you could see each cylinder, the colour of each cylinder. And I said, right, can anyone pick the valve seats that are leaking? And it was, they were all just shocked. There were between 3 and 4 cylinders on a V8 where the power was just being pushed straight out through the exhaust pipe. The valve seats were leaking. So that when the valve closed and then the next intake cycle event was happening, that most of the products of combustion were leaking straight out through into the exhaust pipe. So that cylinder wasn't efficient. The efficiency of that cylinder was gone.
Wasted energy.
It was just wasted energy going straight out the exhaust pipe. So when we developed this kit, we thought we've got to expose, because we come across so many people that had lived their whole lives around engines, and we thought these people have no idea about this. They have no idea, and we were holding seminars, and we were trying to bring these people up to speed. A lot of them were just going straight into denial. They couldn't confront the fact that they'd spent all their lives not realising this one fundamental operation of the internal combustion engine. And as a result of that, they were just part of the brigade that was putting band-aids on the engine. Oh, it's blown another head gasket, we'll fix it. Oh, she's chewing up a lot of petrol, we'll just put more in the petrol tank. It was, we just run the mixture. We can't run them too lean. There's a whole story around that. But essentially what it led us to was to develop the water pump, because that's essentially the most important component on the engine, is that pump. It is just so important. And this is off a 351 Ford V8.
What's the variation?
Sorry?
What's the variation that was needed?
Well, we had to take it. We had to take, in fact, I went around to speed shops and spare parts counters, and I asked them to put their pumps out on the counter, and I bring in some feeler gauges, because water pumps, and I'm a plumber by trade, so I know what water pumps are supposed to do. So when a customer comes to me and they say, listen, I've got a farmhouse, I've got a dam down the hill, I need the water from that dam to come up to my house and feed my house. And I as a plumber, I would have to go, I would measure the distance from the house to the dam, I'd measure how far below the house that dam was, and then I would go to the pump supplier and I'd give them those specifications, and they'd give me a pump that would accommodate that house. Now, unfortunately, motorcar manufacturers call this a water pump. I was going around to speed shops and spare parts counter, and I knew the specifications, and I knew that the impeller design worked for a water pump, a proper water pump. So water pumps have got to be able to push water not only in a straight line, but more up a hill. It's called head pressure. It is so crucial. Now, we set up this old, we got an old kitchen table, and we just got a bunch of Perspex tubing and a Perspex plate, and we had it so that you could bolt a water pump up to this plate, and people could actually see the coolant and see what these things were doing, and knowing what the minimum flow rate should be. Okay, Otto laid out the formula. Okay, he said 10 litres per minute at 500 revolutions. Okay, so most engines, passenger car engines, when you just sit at the lights, they'll idle at about 500 to 600 revolutions per minute. So this thing has to operate at 10 litres a minute. Have you got any idea what sort of pressure that is?
Yeah.
If you go to a kitchen tap here in Melbourne, because we've got pretty good water supply now, our pumps, our pumping stations are fairly high demand. Now, the quickest way to get a 1 litre container, just hold it under your kitchen tap and turn the tap on full bore. It's just about 10 litres a minute. So it should take less than a few seconds to fill that 1 litre container. So that's what pumps have to do at idle. Okay, at idle. Now you put the foot on the accelerator, you open that throttle, You bring the engine up to 2,000, 3,000 revolutions per minute, of course there's more heat. So there's more focus on that pump. It has to really push that coolant through, because that exhaust valve cannot get rid of its heat fast enough. We're talking, milliseconds. We're in a different world here. These things are alive. They've got a force around them. You treat them properly, the difference is just stunning. That ute out there, we put a pump. This is a very similar. This is the upgraded impeller. We put one of these, and this is a factory. This is the same engine as in the Mustangs and the F-150s and the like. It's called a Coyote V8. And factory, they've got a tiny little plastic impeller. I mean, they're just pathetic. All they really do is just make lots of bubbles. That's all they do. And when we set up the test bench, we were getting on average 3 litres a minute. The average Ford Holden water pumps were maybe 1.5 litres a minute at 500 revs. And forget about head pressure. Now, why would we want head pressure in a water pump on an engine?
They're fast.
Because the cylinder heads, coolant passages are very small. So the smaller that passage, the more pressure you need to get the coolant to flow through those cylinder heads. Right? That's crucial. It is absolutely crucial. It's not going to get through and get that heat out. It's all about getting that heat out. And the other big problem we have is we use water. For crying out loud, what happens to water at 110 degrees?
Steam.
Turns to steam. Do we want steam there trying to take the heat away?
No.
It's just bizarre that even today we still put water in the radiator. I stopped putting water in my vehicles years ago. Right? I wouldn't go once I'd been exposed to this system, I was just like, wow, why do we even bother with water or any water-based products? Because water changes state. It can go from solid to a gas to a liquid. And when it goes to a gas, it's not much good when you're trying to use it to maintain a particular temperature in a closed environment. So having confronted water pumps coming out of the factory, motor vehicles and over the counter, the task was fairly clear to then, rather than redesign the whole system, is to take what the manufacturers gave us and make them better. So we were able to do that. So in the 351, that was the engine we first worked on, we took it from 1.5 litres a minute with just this open tin impeller. We put a spot welded just a piece of sheet metal on the back of the impeller, and we clearanced the impeller down to within 15 thou of the wiping face of the pump. And we got it up to 8.5 litres a minute just from doing that at 500 revs. And then we developed this bronze impeller, and we had them cast at a foundry in Altona. And we then set about with a die grinder, just cleaning up the impeller edges and the like and turning it into a proper impeller. And now this puts out 150-foot head and about 15 litres a minute.
Wow.
And the difference is phenomenal. I mean,
is that still enough?
It is. It's tunable. Straight away, it was tunable. It was just, the engine just changed totally. I mean, seriously, I could put a 50-cent piece on its edge on the rocker cover and take that engine from idle to 6,000 revs, and that coin didn't budge. It just performed. And I was using water still.
V8.
Yeah.
6,000 revs.
6,000, like that engine would just spin out so fast. I mean, when that ute out there, when we put the new impeller, and that thing is wicked. It is just, it's another ball game, this impeller. It's 10 leagues above that. We did a before and after on the dyno with that car. We registered all the figures, we took all the vacuum readings, then we put the pump on it, and I changed the fluid. I took the water out, and totally took every drop of water out. There's a special fluid you put in to get rid of all the water. It'll tolerate maybe 2%, but we got as much as we could out. And then we put this nano glycol. It's been developed by the Americans, and it will not tolerate water, but it doesn't change state. And it's about the same viscosity as water. So it works. The military have been using it for a number of years. Our mining industry have been using it for years, and our military use it.
They used it in their engines.
Yeah, absolutely. You know, they woke up years ago that there's a problem. But of course, the domestic market, they don't care because it's all about making money.
Yeah, wear it out quickly.
Yeah, well, they want it to wear out.
Consumer side, build obsolescence.
Yeah. So it's, when we put the car back on the dyno, we couldn't keep it on the dyno. We couldn't. It was just, it started delaminating the tyres. It just started tearing the tyres apart. And I picked up, and for the language, mechanical language is, I picked up about 2 inches of vacuum. So vacuum in an engine is measured in mercury. So, so it had that much more suck. The engine was that much more efficient. Now, when we did the 351, we were getting around about 5 to 6 inches, which is huge, more vacuum. That engine was just, it was saying, wow, thank you very much. And we found the only component that wore out on the engine was the valve guide at 1 million miles. You'd get and in fact the best material is phosphor bronze as a valve guide. Okay, because that's what the valve runs up and down, and it has to be clearanced specifically for whether it's an intake valve or an exhaust valve, it's got to be clearanced specifically. And unfortunately, the reconditioning industry, they still don't really use the proper materials. They use a bronze phosphor sleeve that they put in. I worked in a cylinder head shop for a couple of years, so I know what it takes to set up a cylinder head properly. And this was the next failure in engines, because once you've got the proper cooling system on that engine, what stands out more than anything, if that engine doesn't idle dead smooth, if I can't put a coin on that rocker cover on its edge and run that engine through its peak range, then there's something wrong. And that comes back to how the cylinder head was set up. And that comes back to the machinist. So when you buy a motor car from a factory, the motor car manufacturers have been utilising CNC machines for many years. So if that CNC machine is setting up the valve seats, cutting the valve seats, it might be 5 thou out. But every single valve seat will be the same. You take that cylinder head off that that factory engine and you hand it to a cylinder head reconditioning shop, look out. That's when you're going to have problems, right? And that's when we were confronting the industry as it was, because they don't know how to do it properly. They just do not know.
Performance-wise, did you pass all this through Peter Brock?
Peter Brock.
He's a holding man.
No.
No.
John Bennett, the John Bennett, I'll give you a bit of a history of John Bennett. John Bennett's a fitter and turner by trade, and he had this passion for engines. He saw this cooling system problem back in the late 50s, early 60s. He saw that Fiat got it right for one model of engine, and then they went backwards. He then took what he knew and he was developing and helping hot rodders around Australia, and he got he became a part owner of a business in Doncaster called Headmont Engineering, and it was one of the biggest mechanical workshops in Melbourne through the 60s, and they had interest from Ford Motor Company, and the executive director or the CEO of Ford Motor Company was a gentleman by the name of Howard Marsden. And Howard and John Howard recognised John's talents and what he was achieving down at the drag strips with helping certain people. And he said, well, wow, you seem to have cottoned on to something here that no one else is onto. I was wondering whether you could help us promote Ford Motor Company in racing here in Australia. He said, yeah, no worries. So he said, we've got this Canadian chap that's a racing driver, and we're willing to take him on. Will you build his engines? And that gentleman's name was Alan Moffat. And John set up the first Mustang, the red Mustang, and he built that engine, and that car put Alan Moffat on the map. So then Howard, working in with John, said, well, now we're really pouring some money into motorcar racing, and we're going to bring out a special production run of cars to homologate for Bathurst, which is the big race here in Australia. And John agreed, and the factory, Headmont Engineering, agreed, and they got the contract to build the Phase 3 GT Falcon XY. So John built those. 500 or something of them were built. And John developed that engine, and then Ford changed the design of the motor car. They went to the next model, which was an XA Falcon, and they changed the cooling system. And John said, Howard, you can't do what you're doing. You can't do it. This engine will suffer if you apply the changes that you're proposing. And Howard said, well, this is the way it's going to be. And John walked away. So, Darryl.
Are the things that you've been doing in the past to add, like, what would you call it, add-ons, are they further band-aids in a sense to compensate for the fact that, say, the head is maybe not thicker, the fact that maybe the head doesn't have its own separate supply of coolant, or the fact that maybe the head doesn't have proper heat fins or other fans or other means of cooling it, such that the engine could have been designed better from get-go, and you wouldn't need to put as much effort in after the fact to compensate?
Oh, there's the engine design is okay. Okay, it's not ideal. The biggest problem we've had is there's been no real benchmark. And each manufacturer has had their own idea on how they would design an engine. And some of those are a real disaster. And you don't realise it until you put a proper cooling system on them, and then you go, Well, that was a waste. This design's just atrocious.
So a lot of that stuff, like with the old motors and the old, they used to have like on the rocker covers and down the side plates, they'd have like all the fins and stuff, and like speedway and like on the old motors and that, but it was like, you know, part of it was branding and part of it was like, you know, the concept of cooling the motor down.
Yeah,
But that wasn't like a reality. It wasn't.
that was a band-aid.
It was a band-aid.
Yeah,
right.
they didn't understand what temperature was, how critical temperature was, and what the engine really needed. So they thought, yeah, we blow head gaskets, especially when it's a really hot day, and especially when we race the car and we put a lot of demand on the engine, then we find this thing called heat soak, and the engine just loses its performance. And then you also have a situation where you'll have an engine manufacturer will punch out 10 engines, and every single engine will give you a different horsepower rating. They won't all be the same. And you know, all these things were glaring at them, saying, "Hey, wake up! You know, come on, this is an engineering thing." You know, the accountants, just ignore the accountants, focus on the engineering, focus on what the Otto was trying to tell us back in the midway through the 19th century, and you'll get it right. And no one was doing that. There was an industry building the Band-Aids. And that industry is still going today. They're devoted to applying, but what they've done of late, especially since the late 1980s and early 1990s, they've put a computer under the engine bay.
So how's that solve anything?
Well, what that does, it overcomes a couple of problems. One of them was fuel distribution. So in the old days, there was carburetors, and a carburetor was usually in a V8 engine, was sitting right in the middle, and that relied heavily on proper design of getting the fuel from the carburetor to each cylinder evenly, and that was never ideal, just because of the sheer size. And they found that by putting a carburetor on each cylinder, that was good, but it was very expensive, and it had a whole bunch of other problems that existed, engineering-wise. So they thought, we'll just stick with the basics and she'll be right, and we'll just keep getting away with it. And of course, once we developed this kit and we were then able to put this kit on these engines, just go, well, that fails, yep, that fails, oh, that one's not a bad engine. You know, we'd see the truth was really standing out. And we were then holding these seminars and showing motor mechanics the basics and engine reconditioners. We were saying, guys, it's so important that you get your head around what we're trying to say to you. You know, we've developed this kit to say there's a problem. Okay, there is a problem out there. We've developed it. That shows up the problem. Now you guys have got to get your head around it and then come back and say, okay, how do we fix it? And then we'd say, yep, there you go. Now we put that on there. And we'll put the proper pump on there, and then let them get their heads around what that means, which basically means everything they've learned and everything, all these Band-Aids they've been applying for many years, decades, they just go, well, that doesn't work, right? That doesn't work. Too much fuel. The moment you pour excess fuel into an engine, it starts overheating. Engines want excess air. They don't want excess fuel. And this is one of the other problems of the system.
Wasn't that what a supercharger was supposed to do?
No, superchargers and turbochargers, they put extra pressure. So they raise it from 1 atmosphere up. They'll up the pressure going into that cylinder. So that's just getting more bang. That explosion's just bigger. And when that happens, there is even a greater emphasis on the cooling system. And of course, they've gone, oh, well, you know, the supercharged engine's great. It puts out heaps of power, but it's only short term sort of thing, you know. We've got to let it cool down. You know, we can't let it because it taxes the engine. Well, no. You know, we developed, based on water. What happens to water when you heat it up? No, what happens to water physically when you heat it up? That's it, it expands. Right. So we have to allow it to expand within the cooling system. It's a closed system in an engine. We have to allow that coolant to expand. As it's being heated up, all that heat's being pushed into it. It has to have somewhere to grow to. If we don't give it that place to grow to, it will then it will nucleate, and it will just turn to steam. And steam is the mortal enemy of engines. Okay, it has to grow somewhere. So for a supercharged or a turbocharged engine, you need a minimum of 6 litres of expansion room. 6 litres. That's a lot of room. Okay, none of these, that ute out there, that's a supercharged factory engine. It doesn't have that. It's got about 1.5 litres. Okay, which is one of the other reasons I stepped right back from water, got rid of the water-based system, and put the nanoglycol through.
I ask what ute are you talking about?
The blue one.
God, look, I might have missed something. I feel like I've left. What sort of car is it?
It's a Ford.
So the nanoglycol doesn't expand as much.
Nanoglycol will expand nowhere near as much. It doesn't change state. All it does, we found it at about 350 degrees Celsius. It just gets excited. It just sort of jumps up and down. That's it. But what it does, it's very efficient as taking that heat away.
So does it have a higher specific heat than water?
Absolutely. It's
actually very high. It's actually, what is it, about 800-900, something like that?
Well, once it turns to superheated steam, yeah.
Just before that point.
Yeah.
Anyway. Yeah.
But it's already changed state. And of course, the answer that we've applied to modern cooling systems is we up the pressure inside the system to try and get it to survive longer. But the biggest problem is this thing called nucleating. Well, we heard the term nucleating. So that's a low pressure vapor bubble. So an example of a nucleated water, if you get an aluminium pot, just fill it with cold water out of the tap, put it straight onto a gas stove and turn the gas flame on. And pretty much immediately you'll see these bubbles sticking to the wall of the pan. Yeah. Okay. Now picture yourself inside the cooling system, inside the cylinder head, and you're looking at the back of that exhaust valve seat. That's what you're going to be looking at. There's all these bubbles.
And they're going to be insulating.
They're actually insulating. They're a barrier between the coolant and the valve seat. And it gets to the point where they all join hands and form one big bubble. So by the time the thermostat's opening and the cooling system's rapidly working away, the coolant's going straight over the bubble and out.
It's that sticky.
It's that sticky. And that's what I was demonstrating to these guys on this chassis dyno. I was showing them the cylinders that were doing that. Because the cylinders that were this dull orange, they were working. Because they were exposed to a very rapid movement within the cooling system. So the coolant was moving rapidly enough to keep those bubbles away. But the ones that were glowing bright orange, well, what was the point? It was just a constant leak. You know, and this is what it's so crucial. We were taking exhaust temperatures. That's another good way of gauging whether your cooling system's working or not. We were dropping 120 degrees Celsius into exhaust temperature just by putting a good pump and that thermostat kit. 120 degrees. I mean, it's incredible. You know, these engines just totally change, and they've all of a sudden become tunable. So they don't want excess fuel, and all of a sudden they're not punching out all of this unburnt fuel into the exhaust pipe and into our atmosphere for us to breathe. They're not doing that. It's more efficient. So the thermal efficiency is increased in the engine. So then we're able to give it a leaner mixture and a leaner mixture. We had a bus engine that we took, it was a diesel motor that we took off diesel and we put LPG, propane, into it. We gave it spark plugs. We took the diesel injectors out, and we were running that engine at 30 parts of air to 1 part fuel, and it was still producing power. Okay, now, for engineers, they would just say, oh no, you can't do that. No, you get what's called lean burn misfire at 23.8 parts of air to 1 part fuel. In other words, what happens, a piston will either blow up, a hole will blow in the piston, or there'll be some internal damage occur if you've got a stock cooling system motor. 23.8 is the limit. Well, we're getting it at 30 to 1. We've had an engine on the dyno running at 55 to 1. Okay, to show you the ability of these engines when they're treated properly. It is crucial. Here we are today, we're confronting these new fuels. Hydrogen. Oh, we'll put hydrogen into the engine. No, we did all the work on that back in the 80s. Hydrogen's not good for an internal combustion 4-stroke engine. No, it is not good.
Where's it out?
Sorry?
It wears it out.
Where is it?
No, it wears out the engine. doesn't
Oh
it?
yeah, it does. It wears the engine out.
What do you mean internal full-stroke combustion engine? That's any engine.
Any 4-stroke engine.
Is it better off than hydrogen fuel cells?
No. We've developed, there is a fuel for the future. It's called a low emission fuel. It's a combination of petrol, ammonia, and methanol. Okay? Those 3 fuels mixed together will give you what's called a low emission fuel. Okay, and we're targeting mainly diesel trucks and ships. Okay, we're not worried about, because John and I walked away from passenger vehicles and motor mechanics. We just said, we've had enough. You guys have no idea what you're doing. We spent 12 years banging our head up against a brick wall. We just said, you just don't get it. So then we went to diesel engines and we did the bus. So National Bus Lines gave us a bus and we spent 12 months on that. It had a Mercedes 6-cylinder with a man diesel, huge engine. You know, we had it set up on a dyno in the factory in Airport West. The steel frame with the steel box tubing just to hold this engine in place on the dyno was just monstrous. But I could operate that engine once we'd converted it to run on dry fuel, LPG, either butane or propane. I could operate that engine with the muffler right here at wide open throttle, and I could still talk to you. And the 50-cent coin test, it passed. And that engine was idling at 250 revolutions per minute. 250. Now, we put that motor back in the bus and we said, we lent it because we essentially purchased it from National Bus Lines. We gave it back to National Bus Lines for about 6 weeks and they were just in shock. They said the biggest change that we noticed was, and especially city buses, when this thing was sitting at the lights idling or at the bus stop, the bus drivers thought the motor had stalled. So they kept hitting the starter button. It was that
What
quiet.
about the fuel economy?
Fuel economy, well, it just goes hand in hand. Less fuel you put into the engine.
Did they notice?
Oh, absolutely. Absolutely. They just come to us and said, listen, we've got another 351 buses out there. When can you convert them over?
Oh, good.
So is it like half the amount of fuel or something?
Oh, yeah, we demonstrated the vehicle could run at 30-to-1 air fuel ratio, but then because of the fuel that we were using, we had to richen it up in order for it to give the maximum amount of power. Okay, you were still able to produce power at 30-to-1, but it wasn't the maximum amount of power. We had to then scale it back because each fuel has its own flash point, its own temperature which it will combust. Okay, so the ideal is what's called stoichiometric. So each fuel, like petrol has a stoichiometric of 14.7, LPG has a stoichiometric of 15.7 parts of air to 1 part fuel. And I was comfortably able to run that 351 all day at about 20-to-1, and I didn't notice any loss in power. It was marginal, but not really, noticeable. So I was quite comfortable. I had a little air fuel meter and it's not overly accurate. I would plug it, I'd have a O2 sensor that I would plug into the tailpipe of the motor vehicle and then drive it around and tune my engine accordingly. It's not the best place for an O2 sensor. Ideally, they've got to be as close to the engine as possible to get an accurate reading. But it gave me a rough ball and park sort of figure. It was okay for tuning the vehicle on the street. And yeah, they were fine. They were running around quite happily at 20 plus, but max out at 20-to-1.
The old Buicks used to have they could tune the motor from the steering wheel.
Yeah.
With the rods and stuff.
Yeah, absolutely. In fact, the old Studebaker, I was exposed to a custom-built Studebaker. It was the people that started McRobertson Sweets. They had this car specifically built for them, and it had a V12 engine. I can't tell you, it was about 1932 or something, and it had this carburetor about that size sitting in this massive expanse of cast iron, and that thing passed the 50-cent coin test.
Wow.
From the factory. Like I said, before World War II, our engines were okay. After World War II, it's just game's over. They are just built to fill bank accounts.
I wondered how they run those tanks and that for so many miles with such, where did all the fuel go? They must have had good motors back then.
Absolutely. They had, like I said, Ford guaranteed that Ford V8 would get 30 miles to the gallon back in 1930, 1933. Why were they able to do that? Because they had a fair idea what the engine was, what it required. So it had
Can you fit one of these to the Hilux? Because that thing is terrible, mate. Well, I reckon it's $150 for 100 Ks.
Yeah, and here we are, 2022, and has the computer really worked in our engine bay? Has it improved our fuel mileage? No, not really. Not that much. Not for the amount of work that's gone into it. Not for the amount of engineering that's been poured into that engine.
Disastrous, the whole thing.
It's a piston-based world, and we need to get our heads around what's needed in order for that to survive. Because the piston engine is a wonder in and of itself. We haven't even tapped into the true potential. Because one of the things we did find was our engines are way too big. We can reduce the size of the engine down quite dramatically to get the same amount of power. So we can still, the internal combustion 4-stroke engine can survive as long as we treat it properly. And when we do, it won't pollute and it will just run effortlessly for many, many years. Although people that make lots of money out of them won't be happy with that. But that's the harsh reality.
So that car out there, how do you, what have you got? What can you say about the car out there?
Well, Ford Motor Company kept an eye on what we were doing in Airport West.
Right.
And when the EA Falcon...
Is that like Men in Black?
No, no, they were intrigued.
Yeah.
And they actually brought, in 1989, Ford changed the design of their passenger car fairly radically and developed another engine for it here in Australia. It was the EA Falcon. And they had some problems. They were blowing head gaskets. Pretty much the moment that engine was up on warranty, it would blow a head gasket. So Ford actually came to the factory. They brought a dual fuel car over and we looked at it, and John said to me, grab a level for me out of your truck. And a couple of the Ford engineers were there, and I grabbed a level out of the back of my plumber's truck. And you know, the Ford engineers had explained, yeah, we've got problems with this engine. And John said, he put the level on the rocker cover and he said, there's your problem. Took him 2 seconds. These guys were just like, what are you talking about? And he said, well,
It's out of level.
no, the engine was dead level in the engine bay. And he said, what have you done? I'll take you back to the earlier model Falcon, the XF and the XD Falcon with the 6-cylinder in there. And he said, they were like that in the engine bay. They were high at the front. He said, why was that the case? Well, we don't know. Well, guys, it was so that if any steam had built up in the back of the engine, it was able to migrate its way out. But the moment you stood the back of the engine up, the steam was just gathering and building up and building up and building up. It couldn't get out, and eventually it found a way out. Because steam is very efficient. It will cut through anything. And we actually measured the temperature back there, and it was superheated, over 1,000 degrees. It was just cutting its way through the alloy, and it was making a shocking mess. So John just grabbed a drill, because we had a precursor to this car coming around. We had a cylinder head delivered to us, and we'd analysed the cylinder head. And he just grabbed a drill, and there's next to where the exhaust manifold bolts up to the cylinder head, there's these little casting bumps. So we just drilled a hole straight into the back casting bump and tapped into the coolant passage, put a little fitting in there, ran a hose to the thermostat, one of the hoses off the thermostat. 9 kilowatts more power at the rear wheel. 9 kilowatts more power. There was a 17% increase in fuel economy on LPG and 27% increase in fuel economy on petrol.
So did they change the model after that?
No, they didn't really. No, they looked at us and they went, sorry, but that would cost Ford $20 for every single car, and that's too much.
Oh, but how much does it cost for one?
They get to sell a new car, though.
When are we gonna fix our cars? All the cars that we've been.
Hold on, this must
When are we gonna do that?
That's what they said. They said, that's going to cost us $20. So they said no. And then they changed the design, and and they brought out what we now call the barometer, which is 4 valves per cylinder, and it was better. It was a vast improvement over the past. They had very good water pumps, those engines, but the installation engineering was incorrect. So we corrected them on their thinking. They then released the next engine, and that's now set a sort of benchmark. It's getting world renowned, that engine. It's extremely powerful. They're getting up to 2,000 horsepower out of those engines. So, they still are not ideal. We've sussed out a couple of points where they do trap steam still if you're going to run water-based systems. But it is a vast improvement over the earlier engines.
But it doesn't deal with the cooling.
The pumps are okay, but the cooling is not too bad. It's just these couple of steam traps. Otherwise, they're okay. Because they got a decent.
All the other makers as a result of that, they're better than.
They have learned, and they listened to what John and I were saying, and it's that engine's now quite a good engine, but it's still not ideal. We still need to get through to these people that there are more changes that need to occur.
So is this part of the thesis that there's an artificial scarcity because the resources are not being used efficiently?
Oh, very much so.
But that's in every area, isn't it?
Pretty much.
It's like, people, like we receive offers and we throw it in the bin, it's a natural resource and we just discard everything.
Yeah.
So have you considered developing your own engine?
It's everywhere.
John did that. He developed an engine that had no coolant running through it. It was just using the engine oil, utilising the engine oil, and we took it to the Lyon Institute in France, and they put it into this dyno room, and they did everything they could for 6 months, 24/7, to try and kill that engine, and they handed it back frustrated, saying, "Get out of here," because they couldn't kill it.
So there's no money in it?
Well, yeah, we ended up using that engine as a doorstop in the factory.
Well, have you considered selling it locally?
No, because you see, we have to wake up to where we've gone wrong first. It's no good giving you the solution, because typical people won't see where the mistakes have been made. If Otto had have done what John had developed, if he had have done that back in the mid 19th century, then it would have been a different story, because we would have confronted perfection from the beginning. But we haven't, and
But people would buy it though. If you had it, people would buy it.
Oh, absolutely. But they would just, it wouldn't be the same. We wouldn't have confronted the mistakes of our past.
But it would force the industry to look. If people were trashing or getting rid of their own, the engine that they bought and replacing it with one that it would change the industry, force them to.
It's a matter, like Mercedes-Benz eventually took on what we were doing through their truck fleet, and they listened to us and made some changes as well.
Did you get a hefty consulting fee?
No. John was getting royalties through the kits, but.
So it's a result of Mercedes taking it on. Do other truck makers now see that as a
to a degree, yeah, they have started to wake up. There have been some hot rodders in America that have been sort of cottoning onto this whole cooling system thing for a number of years, and they haven't got onto it. So what I've got there on the table makes a dramatic difference. It is about 40 years ahead of everywhere else in the world.
What about the air-cooled VW?
Air-cooled engines, the biggest problem is there's too much temperature variation around the engine. And this is what I was saying, any more than 10 degrees Celsius variation, forget it. ideally there should be no more than 2 degrees Celsius variation. Now, we were measuring 40 degrees Celsius variation between water in and water out. You know, engines, if your body temperature varied more than 5 degrees, where do you end up? Yeah. And yet we expect 40 degree variation plus. And I watch some hot rodders and they try and pack dry ice around the radiator, and it's like you guys have just got no idea or concept of what you're doing, the damage, and then they're trying to cool down the air charge to the point where it's almost ice going in it. The thermal shock that takes place in that engine is just phenomenal. It breaks things. That's what happens. Engines just break, and then they go, oh no, we'll build it stronger. No, you don't get it, guys. You just don't get it. It's just, it's crucial that you understand where the problem is. Once you understand that, and you're able to focus on that exhaust valve seat, and then everything just changes. And the engine just says, yep, I'm now here to produce power out of every cylinder, and every cylinder is going to do the same job, and it's just going to purr like a kitten. And it'll just...
So what happens, say, if you want to, if you're like me and you say, oh, this sounds like a great idea, and you want to put it to the car that I'm using,
So you hang up the wrench?
How do you go about that?
You hang up the wrench and you're doing a sales pitch?
We stopped producing these kits.
There's one there, how much do you want for that?
No, that's a historical, that one.
$20.
No.
You stopped producing because of...
There was more kickback because a lot of mechanics were going, hang on, the moment I put that kit on that engine, I have too much trouble bleeding it. Now, with some cars, the Falcon V8 especially, you would literally have to put the front of the car on a 30-degree angle to get all the air bubbles out. Because if you didn't get all the air bubbles out, that vehicle wouldn't leave the workshop. It just wouldn't. Those steam pockets would just build up in no time, and the engine would just start overheating.
Well, it wouldn't be too hard to do it, make some ramps.
But even then, it's not a matter of, this is what I say, a lot of engines failed. When we put that kit on in a proper pump, all of a sudden that engine went from being, oh, they're a terrific engine, put out heaps of power, to, nah, forget it.
So,
Wouldn't be
so I'd like to have to start from scratch and like make something of my own for the car out there.
Well,
Is that what I'd have to do?
Yeah, you'd have to keep in mind what I've said tonight.
Yeah.
And you'd have to give you an
You
example.
have to pretty much build it or make it yourself.
Yeah. Like, to give you an example, when Alan Moffat was racing for Ford Motor Company while John was building the engines, John gave him a choice of 3 engines to pick from. There was a 354 horsepower engine, there was a 425 horsepower engine, and there was a 500 horsepower engine. And of course, Moffat just said, oh, give me a 500 horsepower motor. Now, what stood out about that 500 horsepower motor, when you looked at the rocker covers, had these 3 big hoses coming out from it. In the Cleveland cylinder head, they've got these big Welsh plugs that are casting plugs in the cylinder head, and they go straight into the coolant passage. He actually took those out and he put fittings and hoses, and he had 2 water pumps mounted to the front of that engine. It was water pumps off an old Toyota Crown 6-cylinder, great pumps. And he took that car, and I've got 2 independent witnesses that were at Bathurst that day. This is before the big day. It was just trialling the cars. And Moffat he left the pit lane, he turned left to go onto the racetrack, and straight away the back of the car just stepped out. It was just laying rubber. He eventually got back after one lap, and he was shaking so vigorously in the car. All he could say was, "Just get that thing out of there. Just get it out."
It's too.
It was just too powerful. So we put the 350 horsepower motor in, and that's what he won all his races. He was using half the amount of fuel than every other race car.
So that was his advantage, pure stops.
Basically, he was, and every other garage was coming past going, "What are you doing?" And John would say, "Well, guys, it's the keys, the cooling system, blah, blah, blah." "Oh, mate, you're just a rocket scientist." So John was branded the professor. And they took no notice of him. And that arrogance is still there today, even more so. I was shocked. I was truly shocked when John said to me, "Okay, if you don't believe how arrogant those people are, then I'm going to send you down to this guy to pick up some car parts." And he's an ex-Bathurst guy. He's one of the gurus. He was in Paran. He had a workshop in Paran. I went down there and I introduced myself, and he was like, "Wow, terrific. Yeah, John's awesome. What are you after?" I grabbed some parts off him. He come down with me and he said, "Wow, so how long have you known John?" "Oh, yeah, blah, blah, blah." And he said, "So what are you driving?" And I said, "Oh, that Falcon over there." "Oh, wow, so what do you got in that?" "Oh, 351. Anyway, I opened the bonnet and he's just gone, "Whoa, what's that?" "The kit." He's just pointed straight to the kit. "What's that?" I said, "Well, that's proper temperature control." "Oh, bullshit." Bullshit. And he stormed off and started abusing me, and I'm just like, "You're, wow." Jekyll and Hyde.
But he never won any races.
Oh, they had, once John walked away, then things settled down. And they were able to get back to their Band-Aids. They were quite happy putting their Band-Aids on and blowing engines up, and rebuilding them, and puffing their chests up in front of everybody and saying, "Oh, no, great." It's just an ego fest. Now, none of them were really doing anything. Now, you take a supercar, which is what they are today, they're called a supercar. You take one of those engines today, they're lucky to get 3,000 kilometres before they have to throw the whole engine away. 3,000 race
What do you
kilometres.
call a supercar?
The V8 supercars.
Oh, right, but on the racetrack.
Yeah, 3,000 race miles, and that's it. It's the motor has to go to scrap metal. They're useless.
Because they're not using that system.
They didn't take any notice of what we were doing. They just pour excess fuel into the engine and they get big horsepower numbers, but like Moffat experienced, there's 500 horsepower, real horsepower, and then there's 500 horsepower from the ego brigade, and they're different. They are totally different. I mean, the car, the whole drivetrain changes the way it operates. It's just uncanny. It's hard to sort of, I had customers when I was fitting this thermostat kit, and I wasn't touching their pump. I was just relocating their thermostat. And they'd get 100 meters down the road and they'd turn around and come back and go, "Wow, wow, what else have you done?" I had the Toyota Land Cruiser. That was a classic. It was 97, brand new Toyota Land Cruiser, 6-cylinder petrol thing. Customers weren't there. They just said, "There's the keys. We're on holidays. Can you fix it for us? Put your kit on." Yeah, right. So they got back from holidays a week later and they rang me back and they said, "What else did you do? What else did you do?" I said, "What do you mean?" It's got double the power." I said, "Really?" I thought it was dangerously slow. I didn't drive it before. I just fitted the kit and then drove it, test drove it, made sure no leaks, everything was operating, it was bled. I thought this is atrocious.
Can I ask what made you stop doing these guns? If you have stopped?
I had, because we ended up being, there was what's called the diesel lobby into Australian politics. So the diesel lobby were really pushing to get all vehicles to diesel, which was the European trend. And John and myself and the people around us were pushing LPG. So we were up against them. And of course, we didn't have the funding, and the diesel lobby was from overseas, and they just overwhelmed us. And politically, they won the day, which is why now most vehicles you buy new, especially SUVs, are diesel. So we lost that battle, and that was us against them. And we then stepped back and just said, okay, people aren't listening. We're not prepared to. We didn't have the money to promote ourselves properly. We were hoping to use the LPG, that alternative fuel, to get on the map. And of course, LPG or propane is the first crack off the well, off the refinery. So when you go past a refinery, you see the tower with the flame. That's the waste propane being burnt off. So propane is, like, when you look at your petrol Bowser, you got three choices. You got 91, 95, and 98. Well, propane's 110.
Wow.
So, and we actually were also working with other fuels. We were working with methanol, not only methanol, liquid methane, okay? So liquid natural gas. Now that's around 150 to 160 octane. And this is why we're now targeting a mixture of fuels, where you've got ammonia, petrol, just 91 grade petrol, and methanol.
When you say now, what does that mean? What are you up to?
Well, that's the low emission fuel that we're pushing. And there's a big plant now down in Tasmania. The Tasmanian government are actually subsidising this plant to make green methanol. Because methanol is used in many industries, not only for fuel, but it's used in plastics industry as well. Methanol is a very clean fuel. Racing, drag races use methanol. You've got to have it's a totally different rule book for methanol, because when methanol is set on fire, you can't necessarily see the flame. So you've got to be very careful with methanol. But we're mixing methanol, ammonia, and ammonia is just basically nitrogen. It's nitrogen 3. So we mix that with petrol, and we come up with this low emission fuel. So that's really the alternative that we've come up with now to this hydrogen crap that we're confronting through government. It's like government look for the opposite and then go for that. It's just, what are you doing? Seriously, people? There are better ways to do this. I mean, we've stuffed it up for decades since the end of World War II with the petrol engines. Okay, now let's go down another rabbit hole with hydrogen.
We got used to, like the joke I made before about being pissed on, right? We're a pissed on society, right?
Basically, piston broke.
Piston broke.
It's like the inefficiencies abound, but there's money to be made in those inefficiencies, right? It's like a classic case is planned obsolescence.
Yeah, but
so it's nothing new.
We're used to it.
That's where, like, for instance, these shittier engines, they're really designed to break. So you buy another one, really?
Only last.
Everything is.
Some of them last.
After warranty.
Ford Motor Company woke up to what John and I and others were doing. Now, this is the water pump off that engine out there, or this is actually another pump for the same engine, but in the Mustang. And you'll notice this housing here, that's for the thermostat. Ford took it out of the top, put it into the water pump inlet. They knew, they watched what we were doing and they went, hey, let's build it into the system. This engine, that 5 litre V8, and that, what's called the Coyote V8, is one hell of an engine. Ford actually engineered that engine beautifully. The way the coolant passages were set up and everything, spot on. They nailed it, which is why that engine, when we did the changeover, it just reacted so well. It's just like, wow. And it's tractable power. It's like the dyno couldn't hold this thing down. But like I said earlier, when you make these changes to the internal combustion engine, the whole drivetrain changes in the way it reacts to that turning crankshaft. When you've got a standard cooling system, we found there is it sets up, because you've got such a mismatch of temperatures, it sets up this vibration. And that vibration travels right through the transmission, through the trail shaft, through each axle, all the way to that tyre. And one of the tests that John got me to do in my Falcon, to get me to sort of understand the changes that have been made, he said, wait till it's pouring rain, take it out and floor it at the lights and just take off. And what do you think would happen? No. Bang! I just took off like a shot out of a gun. It was just like, wow. Because there was that vibration with a standard cooling system caused the tyres to just break loose straight away, regardless of how good a grip they were, to just break loose and she just skids everywhere. Yeah. The moment I corrected the cooling system, I was just grip, bang. It's the same with that. It just grips. It's just instant. It's just straight to the ground, and I'm going where I'm pointing the car. It's that much of a difference.
Big advantage in the racetrack in the wet.
Massive, massive. And you know, this is why the racing fraternity were just sort of turning away from us. But we were hoping that the racing drivers in particular would cotton on to this, because they don't care. They're competing against each other's skills on the track. They just want reliability under that bonnet so they can, you know, get around that track as fast as possible and be in front of each other. But the engineers were sort of not letting that happen to this day. You know,
what about motorbikes?
Motorbikes, John then left, when he left Ford and he left Doncaster Headmont Engineering, he went and played with motorbikes. And he took a Z900, Kawasaki Z900, and he set up this guy's sidecar outfit, right, for racing. And he took that engine, and this is an air-cooled engine, right? And he did what's called offset grind the crankshaft, right? So he changed top dead center. So he brought top dead center down the bore 30th thou, right? That engine was redlining at 24,000 revs. 24,000 revs. That bike was banned. He took it out one season and they just banned it.
Like it's just
it was just gone. This thing was just gone. It just left every other bike just flapping in the breeze.
But who banned it? The industry banned it.
The industry banned it.
Huh?
Yeah. Essentially, since Bathurst started, there's a mob called CAMS, And they're like politics, you know, that's a disease. And the egos take over and they just go, hang on, you're outside the norm, get out of here. We don't care how you've done it, just get out of here.
So it's set up another circuit for bikes, set up another circuit that's free of them.
Good.
You're
No,
a racetrack, wasn't it?
it'll be different. It's too ingrained today. CAMS is, you know, it's a beast in and of itself. You know, it's just too full of politics.
CAMS free circuit.
Yeah, it's a problem. So then John went and set up this little Leyland Mini, and he added like a unique thing with the Leyland Mini engine is the gearbox is incorporated into the engine itself, right? So he added another 4 gears to the engine, and he painted a white line in the middle of the steering wheel at the top, and he put 2 white lines on the dashboard, and he said to the driver, don't take that white line on the steering wheel past those white lines on the dashboard. So, and with those cars, you could do it. As a race driver, you could throw the back of the car out fairly easily to get around a corner. And that was so to keep the drive shafts in one piece. Because if you took it too far, it would just chop out the drive shafts. And that car left all of the V8s for dead. It was just gear ratios. It's just engineering, you know, it's just apply yourself, you know, look at the trees, don't look at the forest. Everyone else is looking at the forest. John's looking at the trees.
There's no such thing as a forest without a tree.
That's right.
I want to correct something you
It's
said.
a concept. Forest. It's just a whole new tree.
Something you said before is you're saying that the mechanics, the engineers were reluctant, resistant, whatever. I wanted to correct you and say that really they're mechanics, because true engineers don't. They look at the numbers and they behave according to what the numbers tell them to do. They don't. A proper engineer anyway. They don't. A mechanic is someone who doesn't really look at the numbers, and they're not as detail oriented. They're not as experimental. They're not as quantitative.
They read the manual.
But even engineers now have changed.
But a motor engineer, if a car came in with a leaking water pump, they would take the water pump off and put it in the vise. They would pull the pump apart, put a new seal kit through it, clearance the impeller to the wiping face, and bolt it back on the car. Today, they take the leaking water pump off, walk over to the recycling bin and drop it in. And then they go to the spare parts counter and they get a box and it's got water pump written on it for that model. I'll give you an example of this. Toyota had a vehicle back in the 90s called the Toyota Tarago. It was a family van thing for carrying around a heap of people. It came in after 6 months of being on the road, still under warranty, comes back to the dealer and the water pump was leaking. So, went into the service bay, and the mechanics unbolted the pump, put it in the recycling bin, walked to the spare parts counter, got a new pump and bolted it on. The car was back on a tow truck 2 weeks later. They had to replace the whole engine, right? Why? Because when Toyota built that engine, they built it with a pump casting very similar to that one, okay? It was made out of cast iron, but it was proper. It was a proper impeller, and it was even clearanced properly. When they got the one out of the box, it just had this sheet metal pressed impeller. No, it was it was in a Toyota box. This was a dealer. And it had one of those sheet metal tin impellers on it. And it totally ruined the engine.
How did the first one fail in 6 months if it was so good?
Well, the pump seal. It would have been just a dodgy seal. Sometimes you get them, you know, it might have been nicked as it was installed or whatever, but it's just the seal. But yeah, that just shows you the how critical these things are. And that's what when I went to these spare parts places and I said, put pumps out in front of me, and I had these feeler gauges because I know that that clearance is 15 thou between the wiping face and the impeller blade, right? And I said, well, I don't need my feeler gauges, I need a ruler. So there was no quality control.
Still is.
There's still no.
Were they
I
made
don't
in
care.
Taiwan?
Sorry?
Made in Taiwan?
Well, it didn't matter. We actually had GMV, who was a pump manufacturer for the Holden V8 here in Melbourne. They recognised what we were doing in the factory, and they said, because they actually had a cast impeller as a factory impeller, so they were delivering those pumps to our factory less the impeller, so that we would work on the die grind the impeller blade and then clearance fit it to the pump and then sell that to the customer. And so they recognised.
What about the Dandy TAFE?
Dandy TAFE, you know, they were shocked. After I showed them that demonstration, and I then put my car on their dyno, and the guy that was operating the dyno, he said, he instructed me how to put it on the dyno, and then he said, okay, I want you to bring the vehicle up to 100 kilometres an hour. And he said, when I tell you, floor it. And I said, you haven't chained this car down. And he said, it's only, it'll be all right. And I've had heaps of these. I've been doing this for 25 years. Oh, I guess we'll all know. I got it up to 100 kilometres an hour, and he said, floor it, and I did, and the car just, the back of it sort of started to step out, and he was like, whoa. He said, in all my years operating that dyno, I have never had a car react that quickly. So it's about reaction time. He said, with a standard cooling system, it's a delayed reaction. So when you open that throttle up, the motor's just, oh yeah, right, okay, I've got to do right. Where with a proper cooling system, bang, it's instant.
So what's the reduction in reaction time for the power down, and what's the increase in power? Right, on average for, you know,
Increase in, power increase is irrelevant. It's like the engine that I had on that dyno was only a 200 horsepower engine. When I built that 351 up, I deliberately put in a camshaft that only lifted that inlet valve 3 millimeters. Okay, not half an inch. Like, you know, these guys, the petrol heads, the hot rodders go, yeah, big cam, you know, we'll just, so it was only putting out 200 horsepower, but it was instant reaction. It was just, for a 200 horsepower engine, and I had a guy, a magazine editor, come around and take that car for a drive, and he was shocked. He'd driven some very fast cars, and he said, this car is just amazing.
And he didn't want it for himself?
Oh, absolutely he did. He did an article just on this kit. He was blowing right away.
Did you get orders?
Absolutely. We sold probably about 10,000 kits.
So hypothetically, what would the difference be if the water pump was just that plate was like, as you say, 15th of a thou?
15th of a thou.
Just that adjustment was done only.
Oh, you'll get an improvement. Absolutely, you'll get an improvement.
Like on the dyno tube?
Yeah.
Just that alone?
Well,
let alone the bypass?
It'll, I mean, you'll get a smoother engine. The engine will run smoother, it will react quicker than it would have if it was just anyone's guess as to what that pump was doing. It will be an improvement. And we always, when we had people come up to the shop, they were, we'd first say, correct the cooling system, make sure it's as good as it can possibly be, then come to us. Don't come to us with a problem cooling system or a motor that's already got a blown head gasket. So then we take that and we show you the massive difference that can be made. One chap had a 350 Chev in an 11-ton tray truck. He was a courier driver, and when he and everyone was telling him it's way underpowered, and we were saying no, it's fine. It's fine. That little 350 V8's a great motor when you treat it properly. Now, when he went over the Westgate Bridge with 11 tons on board, by the time he got to the top of the bridge, he was in first gear.
Really?
To get up that bridge, okay, and get over. That was a 500,000 mile old engine. So he brought it to us, and we said, yeah, the bottom end's fine. We just took the cylinder heads, cleaned the cylinder heads up, made sure that the valve seats were cut properly and everything was leak proof, so there was no leaks. Put it back on, put a proper gas system on it. He was going over that bridge with 11 tons in top gear. And all of his naysayers were saying, who was trying to talk him into putting a bigger engine in, they were just going, nah, this couldn't be. Well, there it is. The evidence is there. And he was one of our biggest promoters. There was an article done on his truck just to show, what can be done and how important it is to engineer that engine properly from the get-go. And you will get the results.
Were there any 0 to 100 tests? Like so many seconds?
Already relevant. You build a hot engine or a free
it's
not going it's a different thing.
It's a different thing. We're talking about increase in thermal efficiency. The engine's not suffering. The engine's not. It's just able to do its job, which is what we've designed it to do.
It's longevity.
It's just long.
What's the temperature of the engine supposed to be?
Thermostat. So it really matters on the type of fuel you put in. Okay. For a petrol engine, your thermostat should be around 180 to 190 degrees, 192 degrees. For an engine that's, say, running on liquefied methane, I want to see that engine glowing. They love to run really hot, okay, really hot. But it comes back to horses for courses, okay?
Well, just the fuel that's at the gas station.
Just your run-of-the-mill petrol, 180 to 192 degrees is okay, no worries.
192 standard.
Yeah, but that's running.
Usually.
But that's running water.
Going by,
Why would you run water?
Every car I've ever seen runs on water. And
that's right.
I don't know what you're talking about.
Yeah.
I've never seen one.
But so, when you realise what the nanoglycol is, you look like the moment I come across this stuff, I'm just looking for an alternative to water to put in the engine's cooling system. Because why would you have water in there? 875 degrees Celsius is when that's the temperature of combustion, and you want water to take the heat away from that exhaust valve seat? No, it doesn't work. It just doesn't work efficiently.
What else does work?
Nanoglycols. The only other thing that will work.
What is nanoglycol? Yeah. It's a nano.
It's a special formula. There's 2 brands in the world. There's Evans, and there's an Australian brand, Liquid Engineering. Liquid Intelligence, sorry. It's called Liquid Intelligence. They're the same product.
So is that
it's thin.
Bit more thick.
No, it's thin. It's the same viscosity as water.
Liquid
Does that
intelligence.
run as a fuel? Does that run as a fuel in the tank? Glycol?
No, that's in your coolant.
In the radiator?
Yeah,
And that does the 10 degrees thing that you were saying? In the
as long as you got a good pump.
Right.
Yeah,
So you
but
can
if
do that in a regular car?
yeah, you can make big changes just by just getting rid of the water. Just get rid of the water out of your
Where do you
coolant
get
system.
nanoglycol from?
You buy it at
Super cheap.
Super Cheap have it. No, I'm not kidding. They
But
do.
hold on, you said you've got to take out the water 100%.
Totally.
Is there a technique to do that?
Yes, there is a method. They've got this liquid that's got to go in first. So you empty the cooling system as much as you possibly can. There's actually a mate of mine down in Seaford. He's got a workshop, four-wheel drive workshop, and he has a device, a machine that does it for him. So he'll run this liquid through first. He'll hook the machine up to the engine and draw the water through his machine and eventually replace it with the it's a conditioner. It gets the engine ready for the nanoglycol, and then he runs the nanoglycol through it, and then he seals the system, and you're right.
So you got different radiator caps and stuff like that?
No. I mean, the pressure, I mean, when you've got a proper water pump, and with this kit, we had engines running where you could do that to the radiator hoses at 100 kilometres an hour on the dyno.
So does this guy do the kit and that? Is he
Seafood
someone
guy?
you can go to set things up?
John now,
Is there, is there like?
John only works at my instruction. Like, he's wound down dramatically. He lives up in Deniliquin now,
What is that?
in the middle of New South Wales.
Does he want to put a kit on the Porsche?
What we do is, I guess what we're trying to say to people is we need to put pressure on the industry and say, hey guys, you've been getting it wrong.
Yeah, but Ford have been watching you for all that time, right? And they've done something about it. So they've done something
Because
about
they want something that's going to keep breaking down.
Yeah.
Money.
But to a degree, that Coyote V8 is a wonderful engine. John looked at it, he wasn't even exposed to it until I introduced it to him. And then that and he was like, wow, and he did some study. And when John studies an engine, he really does. He's got a pretty comprehensive workshop set up in Deniliquin. He's got this massive water pump test bench, and he's got all of these impellers. He's got bins full of these impellers, these stainless steel impellers, like on this. He's got the setup.
That's machined, isn't it?
Yeah, that's a machine. You can see I'll hand it around. You can have a look. Have a look at the veins.
That would say work for a diesel motor, would it?
Absolutely. Diesel engines also
The
react
diesel motor's
very well.
still got a water pump. It's still got a
Absolutely. They're a
thermostat,
four-stroke engine.
Still got a radiator.
Yeah, 100%.
No, they're curved fins.
Yeah, they're curved fins,
Yeah, the straight ones.
and it's all stainless steel. Like, they're a phenomenal improvement in what we were doing with the old 351 back in the early 1990s.
Cleveland ones, I'll have a look at that.
Yeah. Now that puts out 150 foot pressure, head pressure.
Brass,
That
is it?
pump.
Brass?
Yeah, that's brass or bronze.
So can I ask you why, if you were doing it, like say, at a commercial level before, or just doing it for friends, are you saying you stopped doing it? Now you're not selling the kits, or how come you stopped doing it?
Well,
If that was on a large scale.
the diesel lobby pretty much squashed everything. LPG then, the government put incentives towards LPG. Yeah, about 10 years ago. So they were subsidising a customer if they wanted to convert their vehicle over to LPG. And then gradually over a 5-year period, they dropped that subsidy down to zero. And now we've got a situation where a lot of petrol stations don't even sell LPG.
Is this just the diesel lobby that's done
So
that?
the diesel lobby has done all of that. And they've changed the minds of bureaucrats to just focus on diesel. That's the new fuel. And unfortunately, Australia has the lowest quality diesel in the world. If you run our diesel, like especially down south here, in a tractor or whatever, in a really cold morning, it can actually go to jelly inside the lines.
But then doesn't that just affect you on a commercial level? Couldn't you still do residential, personal cars?
Unfortunately, at the beginning of the 1990s, multi-valve engines became the norm. And one of the things that really suffered here in Australia was our engine reconditioning industry, because we didn't have the machinery to cope with those engines. So basically the modern motor cars had a throwaway engine, and it was geared up deliberately to push the economic side and just have cars churn over every 3 or 4 years instead of lasting 20 years. So they were trying to kill the engine reconditioning industry. But what's sort of taken place is a change where now we've more emphasis on fuels. And since the electric cars come in, we're now looking at different alternatives. But it's still a piston-based
We're now
world.
looking at a global disaster.
Well, it is, and now we're looking at this thing called climate change, and that's the big.
What's that?
Well, this climate change is, we can gear that to our advantage. Like, for example, like I said earlier, around Altona, we've got an enormous amount of diesel fuel suspended in the air because of the trucks, just the volume of trucks that travel in that area 24/7.
But the media think the solution is electric.
The media is just full of it.
Yeah.
Media does what it's told because it's paid to.
And this is why we're now focused more on low emission fuels. So we can put this petrol, ammonia, methanol mixture into that diesel engine.
When you say we, please forgive me, when you say we, who are these people that are like wanting to mix these fuels together?
Oh, there's a number of people who have been working, we've been sort of observing.
But surely not in the corporate interests or whatever you want to call it, that they wouldn't be for that, would they?
They're just looking for ways and means
Money.
to money game at the end of the day. These have been mistakes that we've confronted for decades, that have had too many band-aids applied over the decades, and it's led us to where we are today. But we've still got a petrol-based fleet and diesel-based fleet. Now, one of the biggest consumers of diesel fuel, of course, are ships. I mean, they go through an enormous amount of fuel.
Yeah, but when I watch Back to the Future, he used to put banana skins and that in the fuel can. I thought that's where we'd be right now.
But you're wrong. I'm still waiting for my skateboard.
You're still waiting for the skateboard? Bloody hell.
The hovercraft skateboard.
Yeah. Wow.
So that's the problem with the ships, right? It's like everything's been outsourced. So instead of, just buying local apples, they're getting shipped in from China and whatnot.
But you'll find with ships, and that's very interesting, because some countries insist that ships run a particular grade of fuel in their ship before they come into their waters. So ships have to actually pump through a different type of fuel that's more environmentally friendly before that ship can enter into those waters.
Australia's way behind that, I would say.
Well, yeah, Yet we've got one of the best crude oils available. We've got what's called sweet crude, and it's a fantastic product. We can produce the best diesel fuel and the best fuels in the world, and yet
the diesel lobby doesn't want that.
No, they want us. They've shut our refineries down. We're getting all our fuel from Singapore. I mean, this is the insanity that's going on here.
Well, where's everything going? Because I remember flying over, like coming in from overseas in the airplane, flying over Western Australia at night, and the whole of Western Australia was lit up like fields of lights everywhere. Now they just looked like some type of mining was going on 24/7. So where's all that going?
Don't know.
So have you thought of any possible solutions?
Scott Morrison's place.
The problem, that you call mistakes, political mistakes, but I don't think they're political mistakes, and people keep on making that mistake, that they're mistakes. They're not mistakes. It's deliberate corruption at the industry level, at the political level. They're buying people up to make people dependent on shitty products because that's more profitable for the corporation. So where's the wedge to stop that from happening?
Oh, I think we can.
Cottage industry.
Yeah, cottage industries that can stand up, like what's happening in Tasmania. And as long as, it was disappointing that Scott Morrison was putting an enormous amount of emphasis into hydrogen and pouring money into a bunch of criminals up in Queensland, when the Tasmanian government had already started subsidising the green methanol.
By Illuminati. Scott Morrison.
I know, but the fact is, they're starting to push this hydrogen agenda, which really is not the answer, because we just haven't got the infrastructure for a piston engine to take on hydrogen. The pressure that cylinder has to be under is just unrealistic. When you look at the LPG industry, that pressure tank was only 120 psi only. Okay, we're talking 3,000
just to store it.
Just to store it for hydrogen. It's another level, and then we've got to deal with the filling stations. To be able for your car to go up and top up hydrogen, it's not as simple. I mean, we've got the best system.
I believe this stuff has to be done privately, and it can't be done. It's got to be done individually. From an individual basis, Tesla had more than enough ideas for free energy in every capacity, as far as I know. And anyone that's tried to put out something that's sustainable or that works has always seemed to go to disappear.
Well, like for instance,
something that's a proper solution in any field.
But there's a lot of myths out there, and one of the things that John was doing through the 1980s, he was sort of working in conjunction with government. I don't know whether you can remember the Sarich engine, right? Sarich engine. So I actually read the reports that John did on that engine. Now, Sarich was an inventor from, I think, South Australia or West Australia, and he come up with this new two-stroke engine that was going to revolutionise the motor car industry. Anyway, John put it on the dyno. He reckons it lasted. That'd be awesome. Thank you. So John put it on the dyno. I read the report, and he said, "Mr. Sarich, I think you need to go to a factory. It's factory number 4 in Sweden. The car company is called Saab. They've done this the right way." Because what he found, it was just dragging the oil from the sump past the rings. And it was just atrocious. And that report went to the government. They dropped him like a hot spud. And he ended up over in America, and General Motors took him on. Well, they spent something like $10 million, and that was just water straight down the drain, because it never went anywhere. and he's tested, you know, a number of different ideas. One of them, water-based fuel. Oh, you can run down to you can, you know, get water straight out of the river, put it in your petrol tank, and your motor will run on water. No, it won't. Not and be as reliable as a petrol engine. It's just, forget it. There was all these conspiracy theories about just the reliability isn't there. And I even had people who were, I was lecturing to a mob, a climate mob years ago in Mount Waverley, and they were looking at Brown's gas. So they were taking water, and this device was splitting the hydrogen and the oxygen and putting the hydrogen fuel in as a gas into the engine. And I said, no, you can't do that, guys, until you correct the cooling system. You know, all of these fandangle ideas and the like that gets, you know, I've come up with a new additive or whatever, and it's tested, like even Peter Brock did that crazy thing and bolted this thing to the firewall of the car, and it was supposed to change the whole way the car ran. Yeah, it's like, dude, seriously, you know, you've got to, you got to go back to the beginning. You got to go to the guy that actually invented the engine and have a look at his rule book and go, oh well, we haven't followed it.
What was rule number 2?
Well, once you've achieved rule number 1, rule number 2 was don't give it excess fuel. You know, you can tune the engine now. You can do whatever you like with it, but it's not going to flog your wallet. It's going to last a long time. Enjoy.
See you, Darryl. Nice to meet you.
No worries, guys.
Gotta go. Sorry, mate.
And Mark, are you coming tomorrow sometime?
Would you like me to?
I've got a couple, a couple of problems.
All right.
After 12. I see.
John's investigated the ceramic motor, which may not have the same temperature differential problem.
I know. Cast iron was terrific.
For what it's worth, Darryl, it sounds really good. I want one.
Yeah, we all want one when we.
Kind of like the Holden commercial. I want one.
How do we get one?
How do we get one? What do I do now? You left me in what?
Can I just ask one question? Is there a place that we could go that would make these if we asked? What would a direction you could point us?
Yeah, there is a garage in Hawthorne, and he, just near Swinburne Tech, his father was a student of John's, and I took my XR8 to him because he had spent many hours developing all of the cooling system stuff on that particular engine, the V8 for the BA engine, and he spent quite some time. He charges like a wounded bull.
What's his name of the company?
Oh, escapes me right now. It's been years. Matthew, I'll give it to George.
Okay. Yeah,
Keep an eye.
So he would actually manufacture these components?
Yeah, he spent about 2 months on my car, and $4,000 later. But
So
he had to drill. So one of the other
maker.
problems we have a lot with engines is once we correct the cooling system, we find sometimes the cylinder heads, regardless of how well we bleed them, they just trap steam. So we have to drill a hole in that spot. And in the XR8 engines, what's called the Boss 260 engine and the Boss 290 engine, you got to drill 6 holes.
Really?
Yeah. And he developed a special housing for those bleeds to come into. And then he changed the actual thermostat housing to cope with that. Now, one of the things that we did develop was this. And it's called a de-aeration can. Now, an engineer would take one whole day to make that can. That's a day's work for an engineer. And that acts as a water pump as well. So as the coolant's coming out of the engine, it goes in there and then it gets directed around and it accelerates the coolant as it's directing it around, smashing the coolant up against the wall of the can, breaking the bubbles up, and then it distributes it down, back up into the pump. And that's the bypass there, and they're the bleeds for this particular engine.
That?
Sorry?
You need to call it something. What do you call that?
The de-aeration can. And it's also got a built-in expansion space. So it's got expansion, it's got everything in one. It's a huge amount of work. It's all out of stainless steel. And it just worked well. For instance, the Commodore in the end of the 1980s brought out what was called the VL Commodore, which had the Nissan engine in it. Massive problems. Nissan actually pulled the pin because of what GMH screwed up the installation engineering of that engine in that car. What happened, I could go to the showroom, get into a brand spanking new Nissan powered Commodore, get it up to operating temperature, drive it down a hill 1 kilometre long, right? Get to the bottom of that hill, turn around and put my foot to the floor, and I would get maybe 100 metres and the engine would just stop.
Overheat.
It would crack the full length of the cylinder head. The cylinder head would essentially just split in half. And what was happening, it was installation engineering. So GMH, when they put that engine in, the geniuses put so that the bottom of the cylinder head was here and the top of the radiator was here.
Lacking water.
So when I drove that vehicle down a hill for 1 kilometre, it emptied all the coolant out of the cylinder head. So by the time I got to the bottom and turned the car around and put my foot to the floor, I had a head full of steam. Steam doesn't like it. And it just split the head directly under the camshaft.
Bit more than a crack.
You know, and that was, so we then developed this. We put that into the cooling system, fixed. Immediately it was fixed. Everything was honky-dory. We had the salesman.
Come out those holes.
Well, no, those holes were meant for, they're just for a particular design where we would tap.
Where does the steam come out?
Well, the thing is, this then was higher than the cylinder head.
Yeah.
And we had expansion room built into this.
Yeah.
So the coolant was able to stay in the cylinder head.
Oh, that's smart.
Yeah.
But
So-
Nissan wasn't interested in that add-on?
Nissan, no, by that time it was too late. Like, John and I were doing this probably by the time we got onto that problem. And it was the Burson sales manager for Victoria. He brought the vehicle around and he said, guys, can you fix this? And again, we just looked at it and went, what? How can they do this? You look at the Nissan Skyline, same engine, they didn't have any problems. The Japanese set it up properly. But the idiots at Dandenong, they just didn't think.
They didn't go to the tape.
They didn't do it, mate. I don't know where they went. They weren't, I don't know what drugs they were on, but yeah. Yeah, and Nissan just pulled it. They just said, no, we're not, no more. They took the engine and they said, no, we're not having any more business.
Were you also going to talk about oil scarcity?
Well, oil scarcity is just mainly illusion. We all remember the 70s, I guess, when we were told that we were going to run out. You know, peak oil. Well, China, and particularly China, if you went to Beijing in 1988, 1986, predominantly the main form of transport was push bike or horse. And yet in the 1990s, all of a sudden, they started consuming oil and had motor cars. they've consumed more oil just in China than we have in the Western world since the internal combustion engine was invented. That's just China. Then we talk about India. And they've consumed about the same as China. So what about all this peak oil? Hang on. I think we were being lied to.
You mean it's not dinosaurs?
That's not a fossil fuel.
Oh.
Gee.
Ah.
Oh.
But they've got excess oil in the United States now. It's coming out of the ground everywhere.
It's a renewable.
It's plenty back straight, I think, isn't it?
Oh, it just keeps topping up because what they do in the Bass Strait is as they're emptying a well, they're filling it with seawater. They come back after 12 months and it's crude oil again.
Yeah.
It just renews. There's a catalyst. It's a reaction. It's when it's particular soil types, the bacteria in that soil, and when you put the catalyst in, this bacteria excrete what we call crude oil.
Amazing.
It's just in abundance. It's just a renewable. There's our renewable energy. We just have to control the way we burn it. That's all we do. We understand what it takes to put it into an engine or however we burn it, that hydrocarbon, we learn to control that. And it's fine. I mean, there are now coal-fired and natural gas-fired power stations that are fine, you know. But the greenies say no, the emissions. Well, no, not necessarily. We can fine-tune those emissions. And there's also what's called in an engine exhaust gas recirculation. So when that combustion cycle's taken place and the exhaust gas is on its way out through the exhaust pipe, we can actually take it back and put it back into the engine, and it says, yeah, there's still some unburnt fuels there, because when that combustion process takes place, it's a chemical reaction. There are other fuels that come out as a result of that combustion. So we can then put it back with a proper exhaust gas recirculation system.
And does that exist in some place? Has that been developed?
Yeah, John's done all the work on that.
So we're not talking about a super or a turbocharger?
No, but supercharging and turbocharging does help a lot because, of course, that helps you to reduce the engine size down fairly dramatically. You can run higher pressures in the engine and get the result, which is what you want, which is more reliable power. That's what it's about at the end of the day. And depending on how much fuel you put in there. And then we come back to the fuel, what type of fuels we put in. We can mix our fuels up and have low emission fuels. Forget about hydrogen. Let's just focus on petrol, ammonia and methanol as a mixture.
So these mixtures that you've come up with, they burn at a low, I mean, they maintain the temperature. Well, that's cool.
Yeah, it fuels, you've got to look at the engine. When you develop an engine to the fuel. So you set up your camshaft timing, your spark timing and the like to that fuel. So what's the flash point of that fuel? You know, you take whatever that flash point is, and then you set up the engine's cam timing and the like to that fuel. That's why I said a liquid methane engine ideally runs hot. Petrol engine, you want it to run around 180 degrees. You've got to set it up accordingly. And this is why when we were doing the LPG push, we didn't like the idea of dual fuel because propane has a different set of, it's got a different flash point to petrol. So then ideally you would need to tie a computer in, and you would then need to have some sort of variable camshaft timing to alter those specifications when you flick that switch. Because ideally you want more advance when you've got a higher octane fuel.
Probably best to tune it to gas and don't worry about the fuel, just
run it on gas.
Running out.
You know, I ran all my cars on straight LPG, and I went from a standard cooling system 351 in a Falcon, chewing 60 litres up in about 180 kilometres to maybe 240, right? That was the average. And that was average from pretty much everybody, to 600 kilometres out of that same 60 litres.
Some modifications or something, or what?
All we were doing, in fact, we had a company who was the main distributor for all LPG equipment around Australia, and he approached us and said, listen, I'll give you guys one of everything, and you come up with a package, okay, for a V8, right? So we had a Petrol 308 on the dyno, and it was benchmarked at 347 horsepower. We said, right, that's the benchmark. Now we'll try and put the LPG equipment on to match that petrol horsepower output, and we did. We did it. But we had to combine a couple of products, and we had to put 2 gas converters. Yeah, we couldn't run one. We had to put 2 gas converters, and we ran a sprint gas system, which was about the best and most easily tunable. And a mate and I spent many hours just fine-tuning that. We eventually got more horsepower out of it than petrol. So we're just designing the air fuel intake.
So LPG usually runs lean, does it, on most cars then?
Leaner than petrol. It's 1 point leaner, so it's 15.7 air fuel on LPG, where petrol's 14.7. But that's for maximum power output. You know, I was happy to run it at 20 to 1.
You ever hear of the gas research?
Yeah, we met the guy. Yeah, we met the guy, and I can't remember his name now, but we said, you released this product 12 months too early. It was just dedicated to pouring lots of gas down. He got it wrong. So gas research, it looked great, looked really fancy. Wow, that looks impressive, but no, didn't perform. We had a system that really performed, and it looked stock as a rock. So yeah, we're all happy.
Yeah.
See, I filled 2 hours up pretty quick, didn't
Would that be worth raising a quantum leap and say, are we somewhere down the track of breaking the parameters of space and time where we can hyperdimensionally travel?
I think that's out of our hands at the moment. That's well and truly, you know, we've had that technology well and truly hid from us. So, you know, we just got to sit back and pretty much wait, because we're all in a cocoon here. You know, what's mankind done is pretty much put us into a big cocoon, made sure everyone's exactly where we know you are.
How are we keeping ourselves there?
Yeah, how we're keeping ourselves here. Let's just keep it that way so we can control.
Hey, a little trick. You put your phone in the microwave, I don't mean turn it on, signal's gone.
Yeah, because it's a Faraday cage.
Got to be in the PowerPoint, but don't turn the microwave. What's that?
I don't use a microwave, but now I've found a reason to make it.
PowerPoint is the only. I wouldn't suggest to cook your phone.
Yeah, I'll just
It works, it works.
Right,
I thought the fridge was good enough.
I think silver paper does the same thing.
It's
It's nice and thick, yeah. It's probably the 4 we use around the buildings.
Yeah, you can buy an envelope.
You got a crinkle
yeah.
paper and it works fantastic.
Yeah.
I tried it.
But
Just a Faraday
I'm
cage.
redoing the kitchen, so I might put in the microwave. Just
There's so
handy.
much talk about greenhouse gases and all this climate change bullshit. Isn't this a no-brainer to make all the petrol vehicles more efficient so there's less gases coming out? Whatever.
What is a greenhouse?
Cheers.
Well, carbon, whatever's coming out of the exhaust, all of a sudden the fuel is going into the atmosphere. But what does it take? Political will? Or is it lobby groups you're talking about? Yes, or...
We've got a big problem. We've got mainstream media. They control the paradigm. That's it. Have a look at the Nuremberg trials and who they were hanging at the end of World War II. a third of the people that were on those gallows were media.
How much? And what?
1/3 of the people being hung at the Nuremberg trials were the propagandists.
Not much has changed.
Nice.
That's from my smart meter.
Oh, Faraday cage.
I think we've got backing up.
Oh, wow.
Turning it off or something, or?
Smart meter cage.
Yeah, well, my smart meter, my non-existent smart meter, I just put a angle line at the top, angle line at the bottom, a piece of steel in between the two with 2 padlocks. I've still got my analog meters.
Oh, good on you, right.
And when they sent me warning saying, oh, in the next 2 months we're going to be installing a smart meter, I wrote back an email to the CEO, and this Muppet actually signed the letter that was sent and put in my mailbox. So I responded back to this guy and I said, mate, under section 46Z, I think it's 2W of the Electrical Industry Act 2000 says I have to give you my consent. And he went, no worries. And I get this guy lob up once every couple of months. He drives up, gets out of his car, he's got meter reader written all over him. And I've made a little flap in the door so he can lift it up and read the meter.
They charge you for that, don't they?
No.
They don't?
No.
That's what they used to threaten.
So I put that on the outside, but behind the meter,
That's the problem, is behind it.
So you just go to Bunnings and you buy a sheet of lead and hang that behind on the wall.
Yeah, you got to pull the meter out.
It's still a little bit leakage though.
There's leakage just where the plaster of the wall is.
What's the wet for?
Well, that's our old analog meter.
Yeah.
That's not a smart meter, it's a digital meter.
Hey, good morning.
I wonder if there's an electricity.
Yeah, it's got to do it.
Oh, it's just plug in.
Just plug it in.
Yeah.
Well, I guess
It's like a
electrician could do it.
Yeah.
That's enough.
But they won't sign it off.
Well, that's like the measure of the solar panels on the roof, will get the same value when it goes down.
So you do completely.
Yeah, but the
your house back into
problem is the meter readers won't, the industry, like now your gas meter and your water meter relies on that electricity meter to communicate with the system. You take that out, they're going to know immediately. You see, I cut it off at the pass. I just went straight to the act and went, yep, there it is there, that's the section, wrote to them, and they went, no worries, and walked away.
What's this with the
Yeah, that's
meter?
right, the legislation actually, you can choose what sort of meter you can have.
It's actually, section 46 of the Electrical Industry Act is headed Advanced Metering Infrastructure. That's what that section's all about, and it's in there, consent. But once you consent to have it put in, there's no turning around. It's in. And I'm lucky I studied law, so I stepped away from engines and I studied law, and I found the nitty gritties there, and I don't pay tax, and I don't have a spark meter, and I don't have all these problems.
All right, what's your next topic?
No worries.
Book another session sometime.
Yeah. When I've got the
Where do you get this?
top in there.
Oh, look, I can order it through a
Okay.
So my collection, oh, this is just a small part of the collection. But yeah, it's all
What it does is breaks the signal.
it's all fun. So I hope you've enjoyed it.
Thank you very much.
If you type in a Faraday cage, it will explain what it does. Pretty simple. It's an old, that's what's in a microwave.
The company might be able to turn it off.